Hello and good morning and good afternoon, good evening, wherever you are, whatever you're doing. Let's talk about math. We're going to do this homework helper for section 1.5 and 1.6. Let's just get it all done at once. So what we want to do in this first section is we're trying to recognize what type of function we're looking at. And essentially at this point we know three types of functions. We're going to know linear, which is our classic y equals mx plus b, or as I kind of like to think about it in terms of sequences, f of x equals our n sub 0 plus our common difference times x. These are the same equation. We're also going to be talking about exponential, which is an old friend of ours, which is more of an f of x equals our n sub 0 times some common ratio raised to the x power. And we are also going to be looking for quadratic. And quadratic behaves more like f of x equals some ax squared plus some bx plus c. And again, I keep trying to go over these differences to make sure that we're very clear on what's going on here. Linear, we have no exponents. This is our classical line. In exponential, look at how we have some number raised to an x power. In this case, x is the power, whereas in quadratic, x is being squared. So it's whether or not the x is in the base or is the power that really determines whether or not it's going to be exponential or quadratic. So knowing all of this and having this on your note card, let's look at what's going on with these functions. When we look at this d means the domain is all of these points. So let's look at what's going on. We have 4, negative 1, 3, negative 6, 2, negative 1, 1 is 2, 0 is 4, 2 is 5. So when we're wondering whether or not something is a function, those are the major forms that we know, but we also have something we call the vertical line test. Okay? Vertical line test. And so when we're not dealing with one of these common forms that we've studied, we can still determine whether or not it's a function if it passes the vertical line test. And so the vertical line test pretty much means if we have some function, if we were to draw a vertical line across it, if it doesn't cross it twice, then it counts as a function. Mathematically, what that means is that for every x value goes to one and only one y value. Now, multiple x's can go to the same y, but each x can only go to one y. Okay, so if I had an x go to y and an x go to y2, that wouldn't make sense, because what would this mean? If it was going to two y's, here's my x, here's y1, here's y2. If I had an x, y1, and x to y2, it would fail the vertical line test. So let's go ahead and see what's happening. So we have, what are our x's? 4, is there another 4? No. 3, is there another 3? No. 2, is there another 2? Yes. And we can see that 2, negative 1, and 2, 5 are both represented. So what would that actually mean? So it would mean at x equals 2 and y equals negative 1, we would have a point. But also at 2, 5, so 1, 2, 3, 4, 5, we would have a point right here. And because 2 is at both negative 1 and 5, it would fail the vertical line test. So we would say this is not a function. Okay? And so you can do that for all of these. Some of them are easier because they're actually lines. Look at number 3. We can just draw the vertical line across and see that this is, yes, a function. But this one's a chart that we'll have to do similar to this. All right. Comparing rates of change in linear and quadratic equations. The graph at the right shows the time versus distance graph of two cars traveling in the same direction. Which car is on cruise control? How do you know? Remember, cruise control means that you're staying at the same rate. So when we're looking at this, which one is traveling at the same rate consistently? That would be A, because it's consistent. B has a varying rate, though it is increasing. Okay? And then from that, you can go through and figure out each and every step Go through each step one at a time. It's going to explain what you're supposed to do. Next, identifying domain and range from a graph. Remember, domain is possible x values. Range is possible y's. I prefer interval notation, and remember what interval notation is. Whoops, I had that off screen. Domain is possible x, range is possible y's. Interval notation is something where we do the lowest number possible, comma, the highest number possible. We put that either in brackets, which means the low number is included and the high number is included, or parentheses, and that means that that number is not included. So when I look at this one here, what is my domain? Well, my domain is all possible x values. And I see that my lowest x value is -1, and my highest x value is 1. So that represents all possible x values. My domain would go from -1 to 1. I then look at my range. My range is all possible y values. I see it starts at -1 and goes all the way up to 3. So my range would be from -1 to 3. Let's look at this one. Domain is all possible x values. I see that there are arrowheads here. That means it's going on and on and on infinitely. So this would just keep drawing. My domain would keep going to the left. So my domain would be -infinity, that's the lowest value. And then my high value, well, that keeps going on and on forever too. That would be a positive infinity. And by custom, since infinity is not an actual number, we put parentheses and not brackets. Now when I do the range, I'm looking at my up and down motion. My lowest value is at -1 here, right? But my highest value, because there's arrowheads, will go on forever. So my low value is -1, but my high value is infinity. Okay? And so that's how we do these. Next, let's go to our problems for 1.6. So we're going to be transforming lines. We're going to graph the following linear equations on the grid. The equation y equals x, this is y equals x, has been graphed for us. Remember, if we do y equals mx plus b, this would mean our slope is 1 and our b is 0. Sure enough, 0 is where it crosses and it goes up 1 over 1, up 1 over 1. All right. For each new equation, explain what the number 3 does. So when we're adding 3 after the x, what does that do? Well, what that does is this transforms us up. It changes our y-intercept, right? So when I go up by 3, 1, 2, 3, and then my slope is 1, up 1 over 1, up 1 over 1, like thus. So this is line A. Likewise, this says -3. What does this do? Well, this will transform us down. Down 3. Delta still changes our y-intercept, right? So now we're going down 1, 2, 3 here. And our slope is still 1, so up 1 over 1. So it looks a little something like this. B. But now look what happens here. What happens if we put this 3 multiplying into that x? Well, that changes our slope. Changes the slope. Changes the steepness. Right? So now instead of going up 1 over 1, I'm still crossing at 0, but I'm going up 3 over 1, up 3 over 1, and then like this, like this. So now it looks like that. See? So we can see that wherever this 3 goes, a positive 3 moves us up, a negative 3 moves us down. But multiplying by 3 totally changes the slope of our line. A, B, and the original were all parallel, but C is totally off its axis. So we'll go ahead and look at that for the other one for number 2. Or you will. I think you can do it. Next, we're again going back to whether or not it's linear, exponential, or quadratic. Here's these notes down that you should probably have written down somewhere so you don't need to reference it all the time. We're trying to identify whether or not it's a function, just like at the beginning of the last homework packet. Determine what type of function it is. Neither is an option. describe the growth, and express the relation in the indicated form. So if I had 81 freckles on my nose before I began using Vanishing Cream, after the first week I had 27, next week I had 9, then 3. Is this a function? Well, so this is x equals 0, x equals 1, x equals 2, and x equals 3. So we don't have one x going to two values, right? On day 0, they didn't have 81 and some other number of freckles. They could only have 81. So yes, this is certainly a function. Is it linear, exponential, quadratic, or neither? Well, let's figure this out. So at 0, I have 81, 1, 27, 2, I have 9, 3, I have 3. So what is the relationship here? What's going on? 81 to 27 to 9 to 3. Well, I can tell this isn't linear, right? I'm not subtracting the same number. I see that I subtract 6 here from 9, but then I have to subtract a much higher number. I'm subtracting what? 18 here. But then that makes me wonder, okay, 6 has a relationship to 3, 18 has a relationship to 9. Okay, so what's going on? So what I actually see is going on here is there a number that I can multiply 81 by to get 27? Well, let's find out. If I do my calculator and I do 27 divided by 81, I get a third, okay? Am I multiplying by a third each time? So 27 is a third of 81. Is 9 a third of 27? It is. And then is 3 a third? It is. So I'm multiplying by a third each step. I know that 4 will be 1. A third. That means it's exponential. I'm multiplying by the same number. How does it grow? It shrinks by a third. And then finally, make a graph, label your axes, show all 4 points. Okay, sweet. So I will make a graph. Okay, this will be 0, 1, 2, 3, and 4. I have to go all the way up to 81. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these, so I'll count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. At 0, I'm at 81, which is right here. At 1, I'm at 27, which is right here. At 2, I'm at 9, which is here. At 3, I'm at 3, boom. And then at 4, I'm at 1, boom. So we can actually see that curve now. And we can see how it curves. Sweet. That's what you're expected to do for this. Just bit by bit, kind of grind it out. Finally, go. We're going to match each function to each representation. So what you're going to have to do is you're going to have to look at each function and see what's going on with the one in the left and see how it matches the function on the right. So f of x equals negative 2x plus 5. I can tell that that's linear. This is not linear. This could be linear. Am I crossing at 5? Yeah. Am I going down 2 over 1? Yeah, okay, so this might be it. What is this? Plus 2n plus, no, that looks quadratic. Oh, but this is the same thing. You guys see this? These two represent the same thing. They both cross at 5. They both cross at 5. They both go down 2 over 1, down 2 over 1. The only difference is this one is a line, and this one is just a series of dots. So this one is continuous, and this one is discrete. Right? That's the only difference. And so since this is continuous, is this a continuous relationship? Yeah. Yeah, it is. So this is going to be D. This isn't discrete. Now, if this were instead like a recursive function, that's probably what it would be. And actually, when I look down here, I see it written as a recursive function as 12. So this is actually going to be A, because each step is the step previous minus 2. Well, we can't have half steps, quarter steps, fractional steps, decimal steps. So that means this relates to the discrete relationship. Well, this, we can plug in any number in between. We can plug in, 0.1. And if I do 0.1, I would get a little less than 5. So this definitely works for that one. Okay, guys, that's it. Good luck with Chucks. Have fun. Be prepared for the testorino when it comes up.